Hello, everyone. In this video, we are going to study the dot product and its properties. Dot product. The dot product of two vectors u and v is a scalar defined as u dot v is the product of the x components plus the product of the y components plus the product of the z components. The result of the dot product is a scalar quantity. The dot product is also known as the scalar product or the inner product. Consider vectors u and v in a 3D space. And let theta be the angle between the two vectors. If the angle between u and v is known, then the dot product is the product of their norm times the cosine of the angle. While the dot product does not have a geometric interpretation on its own because it is just a number, it is useful in determining the vector projection of a vector onto another vector. And the scalar component, or the length of the vector projection, of a vector onto another vector, as we will see in the next video. Angle between two vectors. Consider two vectors u and v. If theta is the angle between the vectors, then the cosine of theta is the dot product of u and v all over the product of their norms. Let's concentrate on the plane containing u and v, where the angle between the vectors is measured. We can take the cosine of theta and form the following conclusions. If theta is 0, the vectors point at the same direction. The dot product is the product of their norms. If theta is between 0 and 90 degrees, that is, theta is an acute angle, the dot product is greater than 0. If theta is 90 degrees, the vectors are perpendicular. The dot product is equal to 0. If theta is between 90 degrees and 180 degrees, that is, theta is an obtuse angle, the dot product is less than 0. Finally, if theta is 180 degrees, the vectors point at opposite directions. The dot product is the negative of the product of their norms. If the angle is greater than 180 degrees, we can use this angle, or use the angle on the other side, which is 360 degrees minus that angle, and the dot product will fall in one of these cases. Properties of the dot product. Let u, v, and w be vectors and k be a scalar. Commutative. The order of the operands does not change the dot product. Distributive. The dot product is distributive over addition of vectors. Associative. The grouping of a scalar multiple of a dot product does not change the result. Then there are other properties. The dot product of a vector and the zero vector is 0. Multiplying each component of a vector by 0 and then adding the results gives 0. the dot product of a vector with itself is the square of its norm. Because the angle between a vector and itself is 0, the cosine of this angle is 1. And therefore, the dot product is the square of its norm. Example 1. Find the dot product of two vectors if they have the following values. Solution. The dot product of two vectors can be computed using the components of the vectors. A. Substitute the vector components into the sum of products formula of the dot product. Thus, the dot product is 23. B. Substitute the vector components into the sum of products formula of the dot product. Thus, the dot product is negative 11. Example 2. Find the dot product of two vectors if they have the following characteristics. Solution. The dot product of two vectors can be computed using their norms and the angle between them. A. Substitute the norm of each vector and the angle measure between the two vectors. Therefore, the dot product is 3 times the square root of 3. B. Substitute the norm of each vector and the angle measure between the two vectors. Therefore, the dot product is negative square root of 2 all over 2. The formula works whether the angle is in radians or in degrees, as long as the calculator is set at the correct mode before computing the cosine of that angle. C. Substitute the norm of each vector and the angle measure between the two vectors. Hence, the dot product is 3 times the square root of 2 divided by 8. Suppose this is the graph of the two vectors. The given angle is the larger angle between the two vectors. However, if the smaller angle was used in calculating the dot product, the answer would be the same. That is because the cosine of an angle and the cosine of the explement of that angle have the same values. Example 3. Find the angle between the vectors if u and v have the following values. Solution. The cosine of the angle is equal to the dot product of the vectors divided by the product of their norms. A. Compute the dot product of the vectors and their norms. It follows that the angle is the inverse cosine of the calculated value. Hence, theta is equal to pi radians or 180 degrees. This means that the vectors point at opposite directions. Let us draw the two vectors in 3D space. The computed angle is this angle between the two vectors. The angle between the two vectors is pi radians, or 180 degrees. This particular angle measure means that the two vectors point at opposite directions. In addition, because their norms are going to be the same, these vectors are called opposite vectors. However, we can tell if two vectors are opposite vectors by looking at their components. If the vector components of one vector is the negative of the vector components of the other vector, then the two vectors are opposite vectors. Let us recall parallel vectors. Parallel vectors can have the same direction. Which means the angle between the two vectors is 0. Or parallel vectors can have opposite directions. Which means the angle between the two vectors is pi radians or 180 degrees. There is no requirement on the magnitude for parallel vectors. However, if two parallel vectors with the same direction have equal magnitudes, then the parallel vectors are also called equal vectors. And if two parallel vectors with opposite directions have equal magnitudes, then the parallel vectors are also called opposite vectors. B. Compute the dot product of the vectors and their norms. It follows that the angle is the inverse cosine of the calculated value. Hence, theta is equal to pi over 2 radians or 90 degrees. This means that the vectors are perpendicular. Let us draw the two vectors in 3D space. The computed angle is this angle between the two vectors. These vectors are called perpendicular or orthogonal vectors, because they point at orthogonal directions. Which means the angle between them is pi over 2 radians or 90 degrees. It also implies that their dot product is equal to 0. C. Compute the dot product of the vectors and their norms. It follows that the angle is the inverse cosine of the calculated value. Hence, theta is equal to 1 radian or 57.80 degrees. Let us draw the two vectors in 3D space. The computed angle is this angle between the two vectors. The angle between the two vectors is 1 radian, or 57.80 degrees. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.